Hey folks, welcome out there. I'm Ernie Roberts. I am your host for You Got It. You're on Mathline, we're on Mathline, we want to hear you on Mathline, all those good things. But welcome to our show this afternoon. We're glad to have you with us. And I got to go right ahead, and I don't want to forget about them. But we've got three great operators from the Bearden High School Key Club here. Let's say hello to Rhea, Sarah, and Owie, all right? And we're so glad to have them with us. And we want to make sure that they get to work, all right? They're here to do some good community service for their Key Club, and we need to have you folks call in. Give us some math problems to work here live on the air. They are out there ready to take care of you, and you know what? They do a great job. They've been here before. They are very well trained. They're experts at it, and they will take good care of you. And you get to talk to me. We'll work the problems out live on the air here. What better thing could you ask for on a Wednesday afternoon? So speaking of better things, let's start off with a problem of the day, and you folks can give us some calls, all right? A major arc of a circle measures 25 degrees less than 2 times its minor arc. Woo, lots of stuff going on there. Find the measure of both arcs. All right. Now, major, minor, let's look and see what that's all about, all right? If you've got a circle, which we do here, we have a circle. I didn't draw it in because we really didn't know what kind of size we've got. Sure. And what we've got going here on this problem is we want to set this thing up into some sort of algebraic manner, or want to think it through a little bit. Oh, that was kind of a little crazy, didn't I? But anyway, let's talk about what's happening on that. So first of all, we have a minor arc representation, and we have its. What is that thing about? It means these two are connected. This minor arc and this major arc belong to each other. They make the whole circle happen, all right? It's not just any minor or any major. They belong to each other because of the word its. So it says a major arc measures 45 degrees less than 2 times its minor arc. So we're going to do some representation here. Then what we're going to do is remember what happens when we take a minor arc plus its own major arc and get a full circle. You get the idea. So in this case, let's write it through what's happening. And these are arcs, not R's. And I'm going to let this little guy be X. I noticed some of you guys on Facebook, we didn't get any ladies on this one for some reason. I don't know. Did y'all not like the arc question or not? I don't know. But usually have some of our ladies also call in or check in on Facebook just as much as the guys do. But let's see what's going to happen here. According to this, 45 degrees less than. That means we're going to take 2 times the minor arc, and we are going to subtract our 45. Right there it is, all right? Those are our 2 measures. Now, what happens with the 2 guys there, or 2 ladies, or 2 arcs, we're going to say? How about it? I got a little twisted up there a little bit. Sorry, guys and ladies. We're going to add those together and get 360 degrees. So minor arc, we'll take X, add that major, and we'll get 360, all right? So, as things would have it, let's put these like terms together. They look alike because they both have the same X going on here. There's a 1 in front of that X and a 2 in front of the other X, so we're going to add 1 and 2. Hey, you didn't think it was going to be that easy, did you? It is 3X, and we'll subtract 45. On the other side of our coin, we have 360 that has not changed one bit. All right? Everybody good on it? You with me? Now, time to move things, because we would like to get X by itself. So, my friends, what's keeping us from having X by itself? Well, I have a minus 45 that's messing me up, and I got this 3. Now, I'm going to divert to one of our Facebook folks. Ethan said at this point he divided everything by 3. He's thought it would be easy to do that. And you know what, Ethan? That will work. That'll work, all right? And I'm going to pick that up over here in just a minute to show that it will work. But I'm going to go ahead and finish it up like I would probably have done here. And I liked his approach because basically it's going to be easier on the addition and the division and addition and all the good stuff he's going to have to do as we do it anyway. All right. Anyway, let's go ahead and move our add 45 to both sides, because that's what we're trying to do, is move that 45 over. I know I can get through this. And that's going to give us 3x equaling to, it looks like 405. And that's what most of our Facebook folks have been doing on this, using this approach, I think, to do, and I'm going to go ahead and go along with it. Now, divide 3 into 405. I'm going to the calculator. It's going to come out even. You know how I know that? Because I'm going to add 4 plus 5, which gives me 9, and that's divisible by 3. So I know it's going to come out even, so let's just hit it on the calculator and see what's going to happen. Because folks who are doing these things in geometry are already allowed to use those calculators and such. So let's go to it. And I'm getting a 135. All right. Now, that is, which one? That's the minor. So we'll put right in there 135. So what's going on with the major? We know, we hope it's going to come out to be whatever 360 minus 135 is, but let's put it in right here. So you're going to take 2 times 135. That is 135 there, by the way, folks. It looks a little smudgy, doesn't it? And it's going to give us 270. We subtract 45 from 270. I'm picking up 225. Now, I look back at those two numbers. My goodness, they do add up to 360, so that's a good way to tell that we did it right. Now, back over here, split the page a little bit here. What Ethan did, and I keep going back to it on Facebook because it's a creative approach to this, he saw everything was divisible by 3. He saw 3x, he saw 45, he saw 360, and said, well, let's divide everything by 3, which is quite doable. It's called the division property of equality. Very good. Basically, or you could say you distributed a 1/3 through the whole thing. But in other words, he took each of these and divided by 3. So it would take no change of the final outcome of x. So he had x minus 15 equaling, looks like about 120. And then, hey, let's add 15. And we get x equals, goodness, 135 once again. So another way of doing it. That's what I really like about some of these math problems. There's more than one way to get to the final answer. And some of you choose this, some of you may have chosen that one, and some of you may just kind of played with the numbers in your head, but this gets a little complicated. Now, if that had added up for some reason to 4x, we wouldn't have had such an easy shot, okay? But with the 3x part, if you see a greatest common factor to pull out, works great. Go for it. And folks, that gets us started, all right? We are at Mathline. We've got 3 young ladies from Bearden High School waiting to take your calls. Give us that number. It's 844-686-2378. Once again, 844-686-2378. We want to hear from you. Let's make the show rock because it really does when you guys and ladies out there call in. We love to hear from you, and it does. It makes it a lot more fun for me. It makes it a lot more fun for the audience. And, hey, gives the folks who are answering phones a good chance to get a good workout today on their phone answering skills, etc. Speaking of yesterday, we had a young man from Kentucky, Dylan, who pulled a call in here. We got at the very, very tail end of the show. And let me just kind of reprise what went on. And there was a little bit of confusion at the very end. He says, now we're going to do something. And we had a little conversation after the show yesterday. By the way, if you ever call in at the end, and we don't finish your problem, just hang on. We will take care of you once the show's off the air and finish it up. But yesterday we were so tight at the end. And what happened was, this really was a misunderstanding on my part. That was not anything in part of the problem. So I want to go back to go through what happened here. He basically bought 50 items, 55 bottles of an item at $1 each. Okay, $1 each. And he's going to sell 25 of them, and I think the idea was they were going to sell it at $5 each. Okay? So, but the thing was, he also got, then they were going to subtract $2.50 discount. So they took half off of those bottles. So, in other words, what's going to happen, it's not a divided by, it's going to be minus, that should be minus, sorry, minus that $250 discount, all right? So once you subtract that off, you're basically doing $250, all right? So they sold 25 bottles, there we go. His cost was 55 times 1, all right? So $55 was the cost he would pay to buy these bottles at $1 each. So the question was, how much money did he make profit? And the profit turned out to be $750 maybe, but $7.50 over this whole order. Now, he says there's a second part to the problem, which we didn't get to, all right? By the way, Dylan's from Logan County, Kentucky. Shout out to there in Auburn. And we're so glad to have heard from Kentucky yesterday. It was a good time. Now, let me pull away just a second, guys, if you can do that, all right? Now, here was the next thing that was going to go on. we're going to say that X is equal to $7.50. Now, he also said we're going to have a Y that's going to equal to 55. And what they wanted us to do was to basically say that Y was equal to, and I've got a lot of stuff here because this is what he and I did, 55 times that X, all right? And that X happened to be, what, $7.50. So he was looking for one more value, 55 times $7.50. I think he was saying that we're going to do this for 55 times also, all right? So once we got this part, we knew what we needed to do was to come up with two different answers. So Y equals 55 times X was what he told me. And we worked through multiplying, and that's what we got, $412.50. So the Y was equal to $412.50 when X was $7.50. So again, it's kind of like how many times did it happen over and over again, 55 different orders, same type order, what would have happened? What's his problem setting? So there you go, a little bit of finishing. Some of you watched yesterday and kind of wondered what happened there. We had a little talk and worked through it. It was a great little problem ending, and we finally saw eye to eye. I have no idea what the minus 11 was about. Maybe I thought I heard it. Maybe he said 7. I don't know. But it's at the end of the show, things get rushed and so forth, and we were able to sort things out afterwards. So again, that's what we do on Mathline. We work together to try to come to a good solution. A solution's a win-win for both of us there and for especially the students who call in. Folks, this is a community service. It is definitely for you to call in at 844-686-2378 where we can work out some problems live here on the air together. You pose them. We'll try to work them out together, and hey, I'll try to even go on my own with it and stuff and get those going. So again, we'd love to hear from you. That's why we keep saying, give us a call, all right? And we'll see where things go. Speaking of waiting for a call or two here, let's have a Hey Mathline. Guys, can we do that?
Hey Mathline, I'm Tyler from Arkansas. How would one divide 90 ounces of chocolate evenly among 2,700 people for dessert?
Okay, Tyler, good job there. 90 ounces of chocolate. Are y'all getting hungry? I am. I want something kind of sweet tooth there. So chocolate, wow. And make sure I can spell that. This one with the no there in the middle, right? And we're going to evenly among 27 people. Wow. 90 ounces of chocolate split evenly over 27 people. And they would be definitely very hungry. I would be too. For dessert. All right. Well, let's take a look at how we're going to work this one out. I've written down a few little facts about it. We got 90 ounces of chocolate, and we're going to basically try to split that chocolate evenly over 27 people. Now, it's a division problem, basically. It is a division. And it says, can it be done? It can if you're willing to break the chocolate up into smaller than an ounce unit, okay? Let's see, first of all, what would happen if we start with 27 and we divide that into the 90. That's where it begins here. So we're going to end up with, I believe, 3. Everybody gets, if we're calling these pieces, or we'll say ounces, all right? Everybody's going to definitely get 3 ounces. Because 3 times 21 gives us 81. Now, as I look at this thing, we're going to subtract. It's not coming out even. But we are going to get 9. And this is where I like to use the fraction approach, all right? We've got a remainder of 9, which just basically says we've got 9 ounces left to split up, all right, over 27. So what we're going to do, we're going to do a division on that. We're going to say 9 divided by 27. This is the leftovers. And each person is going to get 1/3 of an ounce. How do I know that? Well, it reduces. It reduces. So let's look at that. We can divide by 3. We can divide by 9. Both of those numbers divide by 9, which is going to give us 1/3. So in this case, Tyler, here you go. Each one is going to get 3 1/3 ounces. If you can figure out a way to get that measured out, that weighted out. Sometimes if you're thinking like candy bars, you know, kind of thing, you might be able to break them off into groups of 3, whatever. But I think of chocolate bars there. But anyway, you got ounces, so you would have 3 and a little bit left over for everybody, and a little bit more to whet the appetites there. So there you have it. Good Hey Mathline from Arkansas. That was at Ripley's Aquarium last summer. And we're always so glad to be able to go up there and get some folks who almost like students off the street, but we have fun with it. We have fun with it. Now, fun today. What do we want to do? I want you to give us a call, 844-686-2378. We want to hear from you. Give us some folks calling here. You know, next week's fall break, so I know we got a lot of testing, a lot of things people are trying to get done before the end of their half, I guess you call it, not a quarter, maybe a quarter here, so to speak. But before you head out for those breaks, some of you are already on them, and some of you will be going a little bit later. But we'll be here next week. We hope you'll be still with us and give us some calls and give us some questions and some problems. So in the meantime, I understand. I think we've got a caller. So welcome. Excuse me as I cough in your hair. Welcome to Mathline this afternoon. Who am I talking with?
Lauren.
Lauren, how are you doing today?
Good. How are you?
I'm doing well, thank you. Where are you calling from, by the way?
I'm calling from Knoxville.
Good to have Knoxville with us today. All right, down here in good old East Tennessee. Yesterday we had someone from Kentucky, and that was some fun too. Actually, I think we had 2 people call in from Kentucky yesterday. So anyway, but Knoxville, good to have you today. What kind of problem have you got for me?
I have a triangle has the area of 45 square inches and an altitude of 5 inches. How long is the corresponding base?
So I've got a triangle. Let's go back again. A triangle with area, you said?
An area of 45 square inches.
Okay, 45 square inches.
Mm-hmm.
And you've got an altitude, I think you said, or do you have a base? Which one?
Yeah, an altitude of 5 inches.
Okay.
And it's asking for how long the base is.
Oh, one of those missing parts where we don't just get to multiply and say we're done. It's not that quick, is it?
Yeah.
So, all right, so you got the altitude of 9 or 5?
Of 5.
5, okay,
inches.
5 inches. All right, let's see what we're looking for. We're looking for the base. So I'm envisioning this triangle, and I really couldn't tell you if it's isosceles or right. It could be all sorts of types of triangles, right? I mean, you know, correct to find area, because you basically have a base and an altitude that come together. So what I'm going to do, I'm going to go with the formula we have for that, and to find the triangle area, we would be taking 1/2 times the base, the length of the base, times the altitude. I'll use A for altitude. Sometimes we hear BH for base and height. Since you use the word altitude, that's what it means, all right? So basically, we have 2 of these 3 variables ready to go. Got it? Ready to go.
Yeah.
So we're going to replace and substitute what we've got to do here. How about it? We'll put a 45 in there for the area, because that's what it is. We have a 1/2. We don't know the base. We'll just keep a B there. But we are going to go ahead and put a 5 there to multiply, okay? I kind of put a parenthesis around it. It means the same thing. We're going to say B times 5. Now, what happens is I could take 1/2 of 5 because I can jump the 5 back in here. I could make that 5B just as easily. But I'll tell you what I'm going to do. I am going to make the 45, I'm going to affect it. So I'm going to do what is a nice thing when you got a 1/2, and you say, well, Ernie, why don't you just go and half it? Well, I do. 2 1/2 would be fine. I could do a division on the calculator. But I'm going to play with it and get rid of the fraction. So I'm going to multiply both sides by 2, take a different approach to it. See my 2's go away. And I've got 2 times 45. I bet you can tell me what 2 times 45 is going to give us. What happens when
90.
I double? Yeah, I got 90. Very good. And I've got a 5 times whatever my base is going to be. So all of a sudden, this looks like a real easy equation. That was the idea. If you had another way, you would have 45 divided by 2 1/2. It would still work fine. It would still work fine. But in this case, it looks like our B is going to equal to 18 when we divide 5 into 90, because I'm thinking 5 into 100 goes 20. Drop off 10, we'll drop off 2, and we'll have a base. And by the way, these will be in terms of inches. Now, I'm going to go back to the other method I was about to do. Are you okay with me showing you that, what I was about to say? Let's say I went back and had 45 equaling, I had 2 1/2 times B, okay? Same story, my friends, same story, folks. It's going to be the same story when we divide it out. Let me go calculate it with you on that, because that one's not, it really is not one I would be able to do in my head by using those. Whereas I could do the 5 divided into something, thinking about it going evenly. Come on, little mouse, go where you're supposed to go. And there again, we get 18. So either way you work it, 18 is equal to B. And by the way, I know some of you may be watching at home and thinking, well, I thought it was going to be 9. Well, if it had been a rectangle, it would have been, because 5 times 9 would give us that 45. But remember, we've got to say 18 times 5, which gives us that 90. Then we take half, and we get back to the 45. So really, the algebra, the formula here, is just you're working it in reverse, and you can check it by going back and just plugging it in and getting the area back. Does that work for you?
Yeah, it does. Thank you so much.
Thank you for calling us today. All right. Folks, we've got someone who's set kind of the pace for us here, so go ahead and give us some calls here, and so we can get a few more problems on the air from some of our local folks here in the East Tennessee, oh my goodness, Southeast Kentucky, Western Virginia, Western North Carolina. My goodness, we'll even get you in Middle Tennessee. We've got you all covered over there too. So give us some calls, all right? We got about 5 more minutes to go. In the meantime, we've talked a little geometry here. We've looked at area. We've looked at arcs. Let's just do a quick little function problem here while we're waiting for a call or two. This one, on the surface, looks a little scary, because some of you are going like, what is that F with a parenthesis of 2 and that F, what is it, F period? Well, the key word function, and F stands for function. It's just a nice little way of saying y equals 4 minus 4x. If you were trying to put this on a graphing calculator, you could type it as a nice linear expression, all right? And if you put the y equals into it, it becomes a linear equation, a linear graph. The graph will be a straight line. So you said, what does that have to do with this? Well, it's just a nice way of saying we're going to replace the x everywhere we see it here with these given numbers. And then we're going to eventually do a subtraction. So the first thing we're going to do, we're going to find out what is the f of 2. In other words, if I put a 2 in here, what are we going to get? All right, what are we going to get? Well, let's play it out. That's going to be, f of 2 is going to equal to 4 minus 4 times, we put that 2 right in there, life is good. And where are we? What are we going to have? Looks like 4 minus 8, which equals negative 4. Now hold that thought. Hold that number. Hopefully you wrote it down. All right, that's the best way to have it. Next, what we're going to do, let's find that f of, negative 5. Got to squeeze that negative in there. That equals to 4 minus 4 times that negative 5. Folks, you just join us. That's a negative 5 we're pumping in there. I got a little bit crazy. So what happens when we multiply negative 4 times a negative 5? We get positive 20. So all of a sudden, this thing got a little kind of crazy. This is going to give us 4 plus 20, which gives us 24. Now, as I look at that, problem's still not done, is it? Because we're going to take this part, and what does it tell us to do? Subtract it. So let's do it. Subtracting from that, we are going to get a negative 4, subtract 24. Now, my friends, that's just like saying negative 4 and moving further to the left on the number line. Moving further to the left. So we're going to end up with, looks like a negative 28 is your final value there. And once again, just go back, quick check here. We did get negative 4. That looks good, because if things happen, it could happen in here or here. We go back and check again with this one. This is where you got to be careful. At negative 4 times negative 5, it goes positive on us. It's 24. But now we got to come back and do the subtraction moment of the 2. So there you have it, negative 28. So again, that's our story on that. A little bit of function action there. And hopefully you got that right as you worked along at home with me there. Again, number 844-686-2378. We love hearing you guys. Love hearing you guys. And remember, I mentioned Facebook a little bit earlier, and I'm going to go ahead and give a little credit there. Ethan, I mentioned. Also, David and Mark working hard on that. James doing some sharing for us. I appreciate that. By the way, we love you when you like us. We love you when you love us. And we really, really love you when you share us on www.facebook.com/Mathline Online. That's our problem of the day, that you get a chance to send it to your friends, send it to your colleagues, send it to others, and we'd love to hear back from you. Hear your discussion on it, see what you think about how would you work this problem, what would you do with it. We try to give some problems that are not necessarily open-ended. They'll get the same answer, but there may be more than one way to get to that answer, all right? So that's the thing I really like in seeing some of the dialogue and the interaction on Facebook. I'm getting a little carried away, aren't I? A little philosophical today. Also, the YouTube business, we are there. You can see some of our old episodes of specialized segments and some of our old problems of the day. And we'll try to get some of those new ones up here as time moves along and give you some new things to go back and look. But if you've watched it through on air here, then you can go back and say, oh, yeah, I can do that again now, right? By the way, subscribe to www.youtube.com with a / just Mathline on this one. No online attached, okay? And of all things, we still have our Twitter going on too, so you can always tweet us a question. And you can send us a Facebook question. We get that from time to time. It's always great to hear from you guys one way or the other, all right? And again, thank you, Beard and High, today for being with us. Our 3 ladies did a great job answering phones today. We will look for you guys to join us again next time, and we'll see you then.